Hello and good morning, everyone. We are pleased to welcome Dr. Kerry Anderson today, who will provide a forecast for the 2017 fire season. Dr. Anderson is a fire research scientist with the Canadian Forest Service. He is actively involved in research to predict smoke forecasting, fire weather, and fire behavior. Through his research, he has and continues to develop models to assist fire management agencies in daily operational planning by predicting the potential impact of fires on the landscape. If you have any questions for Dr. Anderson, please write them into the question box during the presentation. I will make sure to ask your questions after the presentation has ended. Just a reminder that the next webinar will be on 2017 hurricane season forecast with Bob Robichaud, a warning preparedness meteorologist for the Canadian Hurricane Center. It will be on May 30th from 10 a.m. to 11 a.m. Eastern. I will pass it now to Kerry.
Hello, thank you very much, Michaela. Yeah, as mentioned, my name's Kerry Anderson. I'm a research scientist with the Canadian Forest Service. I've been here a number of years. I've been presenting these seasonal forecasts of the upcoming fire season for the ICLR webinars for a number of years now, and this follows the same sort of pattern here. So this may be familiar to some of you. Introduction, the Canadian Forest Service has been doing these monthly and seasonal forecasts for a number of years, and this information is presented through the Canadian Wildland Fire Information System. These forecasts are based on Environment Canada's monthly and seasonal forecasts, combined with current conditions that are monitored through the CWFIS and advice provided by provincial agencies. This presentation is focusing, of course, on the 2017 fire season. So the CWFIS is a web page that's a portal to a data mart that we have. It contains a vast amount of information. We monitor conditions across Canada on a daily basis, and and information is presented through maps through the web page. If you see on the left-hand side, there's one on the menu. There's an option for monthly and seasonal forecasts. This will lead you to the data that I'm currently showing today. Very briefly, the basic methodology that goes into these forecasts is we consider the startup conditions in the forest. That's based on the fall conditions, as well as the overwinter precipitation snowfall amounts. Simultaneous to that, we've calculated a 30-year average daily weather for a number of weather stations across the country. Then we introduce Environment Canada's seasonal predictions as anomalies, and we apply them and use that to calculate the fire severity across the country for the upcoming months. Visually, again, let me just recap again. So we look at the fall conditions and we consider the overwinter precip. Independent of that, we've got a 30-year climatology for a number of weather stations across the country. We gather information from Environment Canada that's usually presented in the form of above or below average temperature and precipitation forecasts, and we feed that into the Canadian Forest Fire Danger Rating System to calculate what the upcoming fire weather will look like. The technique uses an ensemble approach. We actually, the CMC, the Canadian Meteorological Centre, runs a model called the CANSIPS, the Canadian Seasonal Interannual Prediction System. This consists of two models, the CM3 and the CM4 models. Each of these is run 10 times to give a slight variation in the predictions with slight variations in the initial conditions. What this ends up showing is it ends up not only predicting what the temperatures will look like, as well as it gives us some sort of measure of the confidence as these multiple predictions come out. Depending upon how closely they agree with each other, we get a sense of how accurate the predictions are. I usually start these talks with a recap of how we performed last year. 2016, of course, was a dramatic fire season, which saw the catastrophic Fort McMurray fire that happened, that affected a number of affected a number of people with something like about 90,000 evacuations that occurred as a result. But as it turns out, the 2016 fire season was actually a below average year, with about only 2/3, about 65% of the area number of fires and area burnt. So this is actually quite surprising to hear. Also, another interesting fact is one fire, that is the Fort McMurray fire, accounted for 1/3 of the area burnt that happened last year. We also saw that shortly afterwards, in the month of June, conditions dropped and created a relatively quiet fire season for the remainder of the year. Most of the fire activity, of course, happened in Alberta as well as British Columbia in May. In June, the conditions started to drop as we saw the collapse of an El Niño event, a record-breaking event that happened. Northwest Territories and Saskatchewan saw some fire activity, but this is minor compared to what we saw in Fort McMurray. In 2016, our predictions kind of indicated that a large amount of the area in Canada was going to be very active in Western Canada, especially in April and May and June. But in beginning June, we started to see this fire danger subsiding quite substantially. The fire activity is shown in these yellow areas, are centered in northern Alberta and in parts of Saskatchewan. When we take into account other factors such as what areas are forested and what areas aren't, and other issues, we came up with a prediction back in April that northern Alberta and Saskatchewan and British Columbia would probably see most of the fire activity in April and May. So I'd like to think that we came up with a fairly correct forecast, at least for Alberta, and we kind of spotted the area of danger surrounding the Fort McMurray area. We also expected Ontario to see some above average conditions, but that did not happen. So as expected, also the conditions moderated over the summer with the collapse of El Niño. So I'd like to think that we did a fairly reasonable job of predicting 2016. Now moving into the 2017 conditions. Again, if you recall the methodology, the first thing we look at is we try to calculate the startup conditions. We use what's called the drought code as one of the indicators of the fuel moisture in the deep forest floor. This is often what's carried over from the fall into the spring. So if we look at the drought conditions, the drought code, in Canada, we see that this large area, especially in northwestern Canada, the Yukon, NWT, northern B.C., northern Alberta, as being an area of high drought code. Much of the interior of B.C. and southern Alberta and parts of Saskatchewan are also in high drought codes, but that's not unusual, especially for southern B.C. Next up, we consider the drought conditions, and for this we use Agriculture Canada's drought monitor, Canadian Drought Monitor, and we can see areas in Yukon, northern BC, and northern Alberta touching on Saskatchewan as being an area of concern. There are parts of Ontario, eastern Ontario, western Quebec, as well as the Atlantic Canada that also is worthy of some attention. In terms of the overall overwinter snowfall, much of Canada saw relatively normal snow amounts except for the northern parts, especially along the 60 degrees latitude band, if you can think of it that way. So a band from Whitehorse through the Peace River area into northern Alberta and into touching into Saskatchewan really was kind of an area that did not receive as much snowfall as normally seen. These orange zones are basically indicating about 50% of the snowfall amounts. This is a map showing a snow water equivalent. This is mid-April, and it's showing again that much of Alberta is relatively low snowfall amount at that time of the year, with much of northeastern Saskatchewan and northern Manitoba as having heavy snowfall amounts. In terms of the current overwinter snow, the snow conditions right now, we can see that the snow cover has retreated throughout much of Canada now. This is not a big surprise. It's almost mid-May, but we see parts of we see the interior of B.C., most of Alberta, and large parts of Saskatchewan, Manitoba, and Ontario are now, and parts of Quebec and Atlantic Canada are now snow-free. So then we take all those factors into account and we look at the spring conditions. So this is the information that's being portrayed in the Canadian Wildland Fire Information System. And right now we can see that most of the focus of fire danger is in Alberta right now, especially in northern Alberta. The southeast portion is primarily agricultural zones, so we're a little less concerned about that. Also, you might notice some disparity between the provinces. That's because different provinces have different thresholds of what they call low, moderate, high fire danger. So don't fret about that. But it's interesting to compare this year with last year. So there is, as you can see, as I toggle back and forth, quite a dramatic change from last year. So this year is nothing, well, nothing is the wrong word. This is much milder than the conditions we saw last year. So that set the stage for what we're looking at right now. The next thing I like to look at is the El Niño conditions. What drove a lot of what happened last year in the Fort McMurray area was the warming, the early spring, and the early snow melt that led to these extremely warm, dry conditions which were conducive to fire, and certainly what happened in Fort McMurray when the fire did start. It took off, and it was in an ideal setting. So we like to focus our attention on what's happening with the El Niño. El Niño, or more formally called the El Niño Southern Oscillation, is a band of warm water that moves around the equatorial zone in the Pacific. As this warm pool of water kind of moves back and forth between Indonesia and South America, it affects weather patterns, especially in Western Canada. And El Niños happen generally on a 2 to 7 year period. They typically last for about 9 to 12 months, and they tend to reach their peak during the winter season. As shown here on this slide, we can see how these ocean oscillations affect weather patterns in Canada. In a La Niña situation, we tend to see a lot more snow along the west coast of North America. We heard of all the rain and snow in California and how much the unusual amount of snow we saw in B.C. this summer. Well, in El Niño conditions, they tend to set up very dry patterns in Canada. What various weather centers do around the world is they each runs their own model to predict what El Niño will do. And as you can see here, this is what we call a prediction plume, where the black line on the left-hand side is the current conditions, while all the colored lines are the various model predictions going out for the next 12 months. So we can see here that there is a tendency towards an El Niño condition coming up soon. We're currently in a neutral situation, but we're moving towards another El Niño. You normally don't see an El Niño officially start until it hits about 0.5 degrees above average. But again, to put things in perspective, last year the sea surface temperatures reached 3.5. So even though we're heading into another El Niño, probably midsummer, this is not as strong as what we saw last year. Again, if we take a consensus of all those models, that about 16 models, we come up with an agreement between these models that El Nino will likely come into effect probably in June and July, and will last into this winter. Now I'd like to move into the predictions that come out of Environment Canada's Canadian Meteorological Centre. So these are the forecasts for the next 12 months. For the next month, they're predicting temperature anomalies, that is, how many degrees above or below average that they're expecting for the next month. And we can see here that it seems to be northern Alberta and northern Saskatchewan appears to be the focus of much of this warming tendency. Most of eastern Canada and British Columbia and the far north are seeing average to below average temperatures, with the exception, my apologies, the exception of Nova Scotia, which is showing some warming as well. If we take a more focused look on the next, on about 1 week from now, we're seeing most of the warming pattern happening in the Yukon and northern BC and western NWT, with parts of Alberta as well. So you're starting to see a pattern here kind of showing up repeatedly of this area of northwestern Canada that seems to be the focus of our attention. If we look at the probability of precipitation, that is precipitation of at least 10 millimeters on one day over the next 2 weeks, we can see that precipitation patterns are kind of looking rather high for the west coast of BC, as well as the northern interior of BC and the Rocky Mountain zone. If we look at eastern Canada, we can see, fortunately, that the rainfall, the extreme rainfall, will be subsiding, but there's still chances of rain hitting much of parts of eastern Ontario and western Quebec. And much of the Maritimes looks like it's going to be hitting a lot more rainfall in the next 2 weeks. Now, Environment Canada runs their CANSIPS model, and they come up with predictions of the next few months. And over the course of the May, June, July period, they're predicting that the Yukon and BC will see above average temperatures over this 3-month period, while this area of stretching from eastern Alberta through the prairies into northern Ontario and Quebec seeing below average temperatures. Again, Atlantic Canada is showing signs of above average temperatures, as well as the Great Lakes area. Precipitation shown on the right-hand side is fairly negligible anomalies. As we move into the summer, as we move into the June, July, August period, now we're starting to see the conditions actually moderate. They're not as high as they were in that first 3-month period, if I toggle back and come back. So we're looking at more moderate conditions in British Columbia, while we can start to see Atlantic Canada start to increase, as well as the Great Lakes area. Again, precipitation doesn't really show much significant departure, except for Saskatchewan and perhaps the interior of BC. As we move into the fall, during the August, September, October period, we're looking at a relatively warm fall again, and that's quite likely the effects of El Nino effect starting to have an effect on Canada. Again, no significant precipitation in these forecasts. Precipitation anomaly in these forecasts. So at this stage, we've got all the information we need. We've got the sense of the snowfall conditions. We've got a sense of the startup fire weather conditions, as well as the predictions of what the temperature and precipitation will look like for the coming months. We put all that information together, and we start to come up with our predictions of what the season will look like. So the month of May, and admittedly it's the 10th of May, so we're already into this month. We're seeing above average conditions, above average, I should also emphasize, over much of Western Canada, with the exception of southern BC and parts of the Alberta foothills. What we're looking at here is worth just a quick explanation. On the left-hand side is the forecasted anomaly. This is whether it's above average or below average. Now, one has to consider the effect that maybe average, perhaps in Labrador, might be soaking wet. So it will be perhaps less wet than normal. On the other hand, in the interior BC, which is often hot and dry already, it takes a lot to become above average. So that's why we turn our attention to the right-hand side, where we're actually looking at the actual forecasted severity rating. Again, southern BC, it's not abnormal to see high levels in the interior BC. But what is a bit unusual is this above average spot around Whitehorse, as well as Peace River area and Edmonton. The prairies, of course, is agricultural zone, so we're less interested in that. As we move into June, now we start to see on the right-hand side this elevated area of high fire danger is starting to cover much of northern Alberta, as well as the Yukon, northern BC, and stretching into the Yukon, as well as parts of southern NWT. And this has certainly gotten our attention. But as we move into the month of July, all of a sudden we see that fire danger drop quite substantially, except for around the Yellowknife, Fort Smith area. And on the left-hand side, we can see that pink area has really withdrawn to this northwestern corridor, as well as parts of Ontario and Quebec. But again, if we look at the right-hand side, we see that even though it's above average, conditions are often fairly much cooler in Ontario and Quebec. And then as we move into August, we can see that the situation has pretty much dropped down to this white area on the left-hand side, which is basically saying normal or average conditions, with the exception of the interior of northern BC and the spattering across the country. As we move into September, we start to see that warm fall having an effect, but again, this is not, the fall we're normally seeing relatively low fire danger conditions, so we're less worried about the fall. But we could see the fire season extending well into September, especially in Alberta and southern BC and parts of Saskatchewan, Manitoba. Now, if I can indulge you, I want to look at a few of these time series that the model is actually predicting, and it might give you a better sense of what's happening. So we can see on the left-hand side, this is the ensemble of predictions for the Yellowknife station. And what we're seeing here is on the left-hand side, we're seeing temperatures shown in pink, the forecasts, are well above the average conditions shown by the black line for much of the summer, with the exception maybe of the month of May as we ramp up. On the right-hand side, we're looking at precipitation patterns. Again, the black line would be the average prediction, the cumulative precipitation over the summer. And we're seeing a relatively even distribution around that climatological line. So in other words, what we're seeing with these two pictures here is that temperatures will likely be above average throughout the Northwest Territories, Yellowknife area, but precipitation will likely be close to average during the summer. So we might see the fire danger, as indicated in the previous maps, peak around June and into July, but then as fall starts to set in up north, it will settle down. In terms of fire weather indices, we like to look at the buildup index, which is on the left-hand side, which tells us approximately how deep forest fires will burn. And we can see the peak of activity is happening mainly in the months of June and in the month of June. These numbers on the bottom indicate the days from May 1st. And the CCSR, the cumulative seasonal severity rating, is above average throughout most of the summer. So again, the lesson we're picking up from this is that May and June will likely be the areas of concern, and into July in the Yellowknife area. Compare that with Peace River, where we see much of the temperatures above average, for the months of May and June, and then start to subside during the summer. The CM4 on the bottom left-hand side tends to overpredict temperatures, so we don't put as much attention on that. Peace River precipitation looks like it's looking below average for most of the summer. So again, this is another red flag or yellow flag concerning the months of May and June. The build-up index is mainly focused in the months of May and June, as indicated on the left-hand side. If we move to Sault Ste. Marie, if you recall, there was a concern about Ontario, but we can see that most of these temperatures, the temperatures are looking above average for much of the summer, but the precipitation is close to normal. So we're not looking at as much fire danger in the Ontario region as we're seeing in Alberta. And this is reflected in the build-up index. It looks like it might peak in the month of June, but the CCSR on the right-hand side is looking fairly normal. Halifax on the west coast, I've indicated that the Maritimes might be a concern. Again, we're looking at above average temperatures throughout much of Halifax, but the precipitation is hovering around the climatological zone, so we're not looking at abnormal precipitation amounts. In terms of the buildup index, we're looking at, again, the month of June being the area of concern. So in summary, our main concern seems to be the northwestern portion of Canada. This is not unusual. This is typical for Canada, that Western Canada sees a lot more fire activity than Eastern Canada on average. Our particular attention seems to be focused on the Yukon, Northern B.C., and Alberta area, as well as Southern NWT. And this might see some fire activity, especially in the spring, mainly in the months of May and June. The Maritimes may also see some activity in the May to July area, but often the humidities in that area kind of in the summer limit the amount of fire activity to the spring. But the big lesson here is most of the indications are this fire season will likely peak in the month of June, and then they will moderate for the remainder of the fire season for practically all of Canada. So compared to 2016, we saw 2016 peak in the month of May and June with aggressive fire activity and with the catastrophic fire in Fort McMurray, and then it settled down again. We may see a similar sort of pattern in the summer, but we're not seeing this strong peak that we saw last May in 2016. One product that we do in participation with the United States Forest Service, as well as our Mexican colleagues at SEMARNAT, is we try to produce a continental scale forecast of what fire conditions may look like in the continent. This helps because often firefighting resources are shared between the three countries. In terms of our forecast, this was produced and released in April, and a new one is due out the next few days. But we had really indicated that in April, some minimal activity, and I think that was reflected in the fire activity that actually happened. And we're seeing a peak in this in the zone of Yukon and Northern BC. That we could probably say is it will be more centric on Northern Alberta now. And for the month of June, we had predicted this broader band of possible fire activity in Northern Alberta, as well as Northern BC, Southern NWT, and the Yukon. That's our primary area. Now, as I said, this was released last month, mid-April. A new forecast will be coming out shortly, and that's what this map is showing now. Is what we've submitted to our colleagues, and again, we're looking at primarily May. We'll see a moderate amount of activity, possibly in the Yukon, Northern BC, as well as parts of central Alberta. Since the 10 days since we kind of put this forecast together, I would probably expand that area in Alberta. But as we see shown in blue, the month of June, we're seeing this broad area covering much of northern Alberta, as well as parts of the Yukon and NWT. And as we move into July, we'll see the focus in on the Yellowknife, Fort Smith area, while much of the rest of the country will subside into normal fire business as usual conditions. I keep on leaving Atlantic Canada to the very end, and certainly we've recognized that we may see some peak of activity in Atlantic Canada around the Halifax, northwest, southern Nova Scotia area. That will likely, if it happens, will likely happen in the month of June. So at this point, that summarizes my forecast for this fire season. Perhaps a little early, but I open the floor to questions.
Thank you again, Dr. Anderson, for this very informative presentation. We will take some questions now, and if you have any questions, please write them into the question box. So the first question, will the presentations be shared after? It will be available on our ICLR YouTube channel. So another question, as you said, the 2016 fire season was actually a below average year, even with the Fort Mac event and the fact that it was an El Niño year. Any ideas on why the El Niño didn't have quite a large impact?
Well, it certainly had a large impact. The peak of the El Niño happened early in 2016 during the winter months of January and February. This led to a warm winter in Western Canada, and it led to the snowmelt happening about a month prior to the normal time. Certainly much of Alberta was snow-free towards late March. This is what set up the situation for the Fort McMurray fire. Now, certainly these seasonal forecasts don't predict down to the pinpoint precision that will forecast a fire such as Fort McMurray, but we did provide an indication that this would be an area of concern. After May, we saw the collapse of El Niño. This kind of happened in March and April and May. We saw the El Niño collapse, and that's what led to cooler conditions. Indeed, we saw flooding activity in Fort McMurray about a month or so after the fire because of the amount of rainfall. I believe Alberta received an abnormal amount of rainfall during that summer. Does that answer the question?
Yes, thank you, Kerry. Again, if anybody has any questions, please enter it in the question box. Does it right at this moment? It doesn't seem like we have any more questions. Kerry, would you like to say anything else?
Just some closing remarks. So you know, the message that I'm giving here is that, you know, what we're looking at is I am flagging these areas as above average fire activity, but often remember that you still need that spark. Just because it's hot and dry out there doesn't always equate to a large catastrophic fire happening. But certainly, you know, we're focusing our attention on the month of June as being the area that will likely be the most dangerous, if I could say that. Afterwards, conditions will subside, but they will subside to average conditions. So it will become business as usual. You will still see forest fires in July and August. I'm not suggesting there won't be any fires, but they will be less active and less likely to see something dramatic such as what we saw last year.
Great. Thank you again, Dr. Anderson, for the great webinar today. Again, just a reminder for the audience that our next webinar will be May 30th from 10 a.m. to 11 a.m. and we have Bob Robichaud coming in from the Canadian Hurricane Center. This now concludes the webinar. Have a great day.
Thank you very much for the opportunity.
Yes, thank you so much, Kerry.